So in this video, we're going to find the length of a circular arc, okay? In a subsequent video, we'll go over the area of a circular sector, okay? But we're dealing with circles here, okay? We've got a circle with radius r, and we've got a central angle here that we're going to call theta, okay? And we're going to use this formula, arc length S equals the radius times the central angle theta, and that theta has to be in radians, okay? If it's not in radians, you're going to have to convert it to radians, all right? So the arc length, this part of the circumference here, is going to be the radius times the central angle, okay? S equals R times theta. All right, so let's do example one and kind of keep this image in mind as we kind of work through this, okay? So we want to find the length of an arc of a circle with a radius of 10 meters. So R here is going to be 10 meters. That subtends a central angle of 3 pi over 4 radians. So theta here would be 3 pi over 4 radians, okay? Think back, 3 pi over 4 radians is 135 degrees. So, you know, we're talking about an arc length that would kind of cover from here over to here, okay? So we're talking about a relatively long arc length there, you know, less than half of the circle, but not much less than half, okay? So let's plug what we know into our formula here. So S equals R times theta. I know R and I know theta, so I'm going to plug those values in. I'm going to keep units here, okay? As you're working through this, kind of think about the dimensional or unit analysis. Arc length is a distance or a length, so my answer would have meters as the unit. So just kind of keep that in mind as we go through this, all right? So let's go ahead and multiply those. So 10 times 3 pi is 30 pi. 4 is the only thing in the denominator, so it stays there. And my units, again, will be meters. All right, we want to be in simplest form, so my exact answer would be 15 pi over 2 meters, okay? That might not mean a lot to you, so let's go ahead and convert that to decimal form. So approximately 23.56 meters would be the length of the arc. Again, it would go from here to about right here, okay? 23.56 meters. Let's look at example 2. Okay? We want to find the length of an arc of a circle with a radius of 24 centimeters that subtends a central angle of 30 degrees, okay? So my radius here is going to be 24 centimeters, and my angle is 30 degrees. So it kind of, you know, this is a pretty accurate piece of the pie for a 30-degree angle, all right? But I can't use angles that are in degree form. So I have to convert this to radian measure before I can plug this into the formula. So if you'll remember, to convert degrees to radians, you need to multiply by pi over 180. And when we simplify, we get 30 degrees is equal to pi over 6 radians. So when I plug that into my formula, okay, I'm going to replace theta with pi over 6, not 30 degrees, okay? So let's plug in what we know. S equals 24 centimeters times pi over 6. Again, we're going to leave our units in there. So we got 24 pi over 6, which simplifies to 4 pi. Again, this is the exact answer. The arc length will be 4 pi centimeters, but as a decimal form, it's going to be approximately 12.57 centimeters. Okay? Now, let's do one more problem, example 3 here. We've got a central angle theta in a circle of radius 4 inches is subtended by an arc of length 6 inches. Okay, we want to find the measure of theta. Okay, so in any formula, you can solve for any of the variables. So here we're solving for theta, not for the arc length. Okay, so let's plug in what we know. So we know the arc length is 6 inches, so I'm going to replace S with 6. The radius I was told was 4 inches. Okay, so this is a pretty easy calculation. I'm just going to divide both sides by 4 inches. Notice that the inches will cancel out, okay? And we know theta has to be in radians, so 6 divided by 4 is 1.5 or 3 halves. Okay, so 1.5 radians. So that's how you determine the arc length of a circle, or if you know the arc length, that's how you can find the central angle that's being cut or subtended by that arc length.